So you see that I have emptied out my hotel, and what we're going to do is start to take electrons and drop them into the hotel, and we want to know where do they live. And there's going to be two rules that are going to tell us where the electrons live. So the first rule is that the electrons will want to go as low as possible. So you can try this experiment. Take a pen, drop it into your hand. All right, now take the pen, but this time go over here and drop it. And did you notice that the pen did not stop at your hand? So the pen went as low as possible. So that's going to be rule number one. So let's try this. If we take our electron and we drop it into the hotel, where's it going to go? Okay, did you make a prediction? So it's going to go down to here. Now notice which subshell is it in. It's in the S subshell. So the bottom floor has one room, and that room holds 2 electrons. So that was called the S subshell. So it's on floor number 1, and then it's in the S subshell. So we then say it's a 1s subshell. And that is going to correspond to hydrogen. So hydrogen has 1 electron, and then notice where it's located at. So it's over here on that side of the periodic table. Okay, now we're going to take 2 electrons. So we drop our first one in there, and then we drop a second one. Where does the second electron live? So it's going to live here because this room has enough room for 2 electrons. So it's still in the 1s subshell, and now we've got helium. So helium has 2 electrons, and helium is over on this side of the periodic table. And now you're saying, well, why didn't they put it right next to hydrogen? Well, there's a reason. We'll get to that later. So helium is on this side of the periodic table in the very, very last column. All right, now we're going to take 3 electrons. So we drop 1, 2, and the third electron into the hotel. Where does the third one go? Well, now it cannot go onto the ground floor. Now, I know that you're wondering why. Well, it's this quantum mechanics stuff. So in quantum mechanics, you have to use calculus in order to be able to explain all of this, but it turns out that you get these very specific numbers of where the electrons can live. So just trust me, it comes from quantum mechanics. So if we drop that third electron, it cannot go onto the first floor, so it's got to go onto the second floor. And now it's got its choice. It could go into the S or it could go into the P. So now we need to use our second rule. So the second rule is electrons would rather go into an S subshell before they go into the P subshell. So that means that the third electron is going to want to live there, and now we've got lithium. And so lithium, if you look back at your periodic table, is now still in that first column, and it's directly underneath hydrogen. And now we could continue doing this. So let's, just for the sake of argument, let's do it for carbon. So carbon is going to have 6 electrons. So 2 of the electrons live here, 2 of the electrons are going to live here, and then the remaining 2 electrons are going to go over here. And you can still see it's got room for 4 more electrons on this floor. And so you can find carbon C on the periodic table. Now there is a method to this madness. So I'll explain to you, why is all of this important here in just a moment. Okay, now we're going to talk about fire doors and valence electrons. So every hotel has fire doors, and the purpose of the fire doors is, in case of a fire, the doors are going to close, and then that protects the different floors of the apartment building. We're going to do the same thing. So we're going to say that once a floor of an apartment building is full of electrons, it has its maximum complement. So on the first floor, the maximum complement was 2. The fire doors are going to close. And when those fire doors close, these electrons are going to be sealed off from the rest of the atom. And so these electrons will not participate in chemical reactions, at least as far as we're concerned, okay? If you want to see the exceptions to the rule, take a chemistry course. So for our purposes, we're going to say that once the floor is full, it's going to be sealed off, and only the floor up here is going to participate in chemical reactions. Those are going to be called the valence electrons. The valence electrons are the outermost electrons in a particular atom. They're the ones that are going to be jumping back and forth from one atom to another to make a chemical reaction. And so, if I was to say, how many valence electrons does carbon have? Well, you could painstakingly know that there are 6 electrons in carbon, and then put 2 down here, and then put 2 here, and then 2 over here. So 1, 2, 3, 4. So it has 4 valence electrons. Well, you could do that, but there's a much easier way. Count columns. Okay, so let's go over to this side of the periodic table, and you have column 1. So every element that's in column 1 has 1 outer electron that participates in chemical reactions. Okay, go to column 2. So in column 2, you have 2 valence electrons. Every one of those elements has 2 outer electrons. And now you skip the yellow part, and now you're saying why? And I'm saying because, all right? We'll get to it later. We're not concerned about the yellow part at all. So let's go over to the purple and green part, and then you got column 3, 4. So go back to find carbon. Okay, find carbon and look at what column it's in. And do you notice that carbon is in column 4? It has 4 valence electrons. So isn't that so much easier than trying to figure out all of this stuff here? You're just counting the column where it lives, and then it goes all the way over to column 8. Very, very important. Column 8. Okay? So I'm not going to ask you anything about the yellow part there. Now, I do want you, though, to count the columns. So if you count the number of columns over on this side of the periodic table, how many you get? The red and the orange, you put that together and you get 2. Okay, then count the yellow columns. Do that for me right now. And what do you get? You should get the number 10, and then count the purple and the green columns. And how many have you got? You got 6. Have we seen those numbers before? 2 and 6 and 10. Okay, if we go back to here, do you remember that the 2s were the S's, the 6s were the P's, and then the 10s were the D's, which I said don't worry about. So where do you think the F's are? The F's are the ones that hold 14. You want to take a guess? they're the ones at the very bottom of the chart. So this is the reason why the periodic table is shaped the way it is, because it's going to be telling you the energy levels on which the electrons live. So those are going to be the rows. And then it's also telling you the outer electrons. Those are the columns in it. And it even tells you for a particular element which subshell is currently being filled up. Is it an S that's being filled? Is it a P that's being filled, and so forth? Don't worry about that. I know I'm saying that quite a bit in here, but I'm entertaining you, and that's the important thing. Okay, now let's take a break. Now we're going to get into some chemistry, and we're going to find out why the most dangerous stuff in the world is sodium, water, and teenagers. Okay, I'll see you in just a moment.